Welcome back. In this video, we're diving into the transformations of hyperbolas, using the equation y equals 1 over x as our starting point. We'll explore how changing the equation shifts, stretches, and reflects the graph, and what happens to the asymptotes along the way. By the end of this video, you'll be able to sketch or recognize these transformations in any position or shape.
Adding a constant outside the fraction, in this term is k, like y equals 1 over x plus 3, shifts the y asymptote up 3 units, or up by wherever this value is. These shifts place the hyperbola in any area of the coordinate plane. We can also note that when finding the x asymptote, remember we said we found out that 1 over 0 is not a value, it's undefined, right? That's why we came to the conclusion for this one. 1 over x, if you sub in x equals 0, 1 over 0 is not a value. X cannot equal 0. We can do the same here. 1 over x minus 2. So this x minus 2 cannot equal 0. So if we have x minus 2 cannot equal 0, then you can do x cannot equal 2, which is how you can find the x asymptote. Now let's discuss stretching and compressing. The a value decides whether the graph is going to compress or stretch. Let's look at y equals 2x, where a value is 2. We look at a large a value, it stretches the graph. Now, if we're letting a equal half, a small a value, the graph comes closer to the axis. It compresses, giving it a flatter shape. So changing the constant adjusts how steep or wide the hyperbola branches are. A horizontal shift occurs by adjusting x in the denominator. For instance, in y equals 1 over x minus 2, the x asymptote is shifted 2 to the right to become x equals 2. When we're looking at reflections across the axis, a negative numerator generally means the graphs in the second and fourth quadrant. Let's look at the normal one. It's in the first and third quadrant. But when you add this negative sign, the graph flips across the x-axis, meaning the first quadrant graph goes in the fourth quadrant, and the third quadrant graph goes in the second quadrant. It's basically just flipped. This negative sign means the graph flips across the x-axis. Finally, let's combine these transformations. Let's look at this graph here. X minus 2, that will shift the graph 2 units to the right. Remember what I said? That you can't have 1 over 0. Well, the same applies here. Negative 3 on x minus 2. Let's see. X minus 2 cannot equal 0. So that means x cannot equal 2. So this will be our x coordinate for our graph. Now let's look at this value here. This will shift the graph up by 1 unit, which will give us a y asymptote of 1. It will shift the y asymptote up by 1. Now let's look at this negative 3 here. What that will do is flip the graph, and it will stretch it as well. Now, having all these transformations, let's sketch it. So x cannot equal 2, so 2 here. Let's dot that. Y cannot equal 1. Let's dot that. And now, our usual one would be in the first and fourth quadrant, but since this is negative 3, we're having the second and fourth quadrant. And since it's 3 and not 1, we'll have it further away from the axis. So the final graph would look something like this. And there we go.
To sum up, we can transform the hyperbola y equals 1 on x by shifting it horizontally and vertically, reflecting it across the axis, and stretching or compressing it. Combining these transformations allows us to reposition and reshape the hyperbola as needed. Thanks for watching, and take some time to practice these transformations on your own to get comfortable with each effect.